Hello everyone, this is lecture 3 of fluid mechanics and hydraulic machines. In the last class we started problems on Newton's law of viscosity. So we will be solving some more problems in this class also, because from unit 1 you will have either of these two questions, that is either there could be a problem on Newton's law of viscosity or there could be a problem from pressure measurement. So this pressure measurement is the second part of unit 1. Now we are solving problems on Newton's law of viscosity. From unit 1 you can expect one 5 marks problem and 10 marks theory. So this 5 marks problem could be either from these two concepts. So it could be a Newton's law of viscosity, it could be a problem from Newton's law of viscosity, or this problem could be from pressure measurement. So since we have solved some problems on Newton's law of viscosity in the last class, we will be solving some more problems because it's very important, and we will also be solving some more problems from the previous papers which were asked from this concept. Okay, so what is Newton's law of viscosity? That is tau is equals to mu into du by dy. Okay, so as soon as you see that viscosity term in the question, you can use this formula. You have to understand that you have to use this formula. Tau is equals to mu into du by dy, where tau is called as shear stress. The unit of SI unit of shear stress is Newton per meter square, also called as Pascal. Mu is called as dynamic viscosity. The SI unit of dynamic viscosity is Newton by meter square into second. So this Newton per meter square is also called as Pascal. Therefore, it can also be Pascal into second. Next is du. Du is called as velocity. So the unit of velocity is meter per second, and dy is thickness. So thickness unit is meter. So all these are SI units of all these terms. Apart from this, du by dy term can also be given in the question. This is called as velocity gradient. So this velocity gradient unit is per second. So anything if you see in terms of per second, that is du by dy value. So sometimes in order to confuse you, he will also give you kinematic viscosity. So like I taught in the previous class, kinematic viscosity is denoted by nu, and it is the ratio of dynamic viscosity and density. So whenever kinematic viscosity is given, you should know the relation between mu and kinematic viscosity. So kinematic viscosity is mu by rho, which is mu is called as dynamic viscosity. So in some cases, instead of giving mu, he will give you the value of nu. So what you can do, you can cross multiply this. So nu into rho will become the value of mu. So that's how it can confuse you. So there could be for 100% you can have a problem on Newton's law of viscosity as per the new syllabus. So next, what else can be asked from this is he can ask you to find out power. Since power is equals to, you all know that power is equals to 2 pi nt by 60. Sometimes he can ask you this. You have to find out the value of torque. In this, torque is equals to force into radius, and this force can be found out by using the formula of shear stress, because this shear stress tau, what is tau? Force per unit area. So tau is equals to force per unit area, shear force per unit area. So once you get the value of shear stress, if you multiply tau into area, you will get the value of this force, and this force into radius will give you torque, and if you substitute this torque in this power, you will get the power loss. Okay, as per the given question, we will be using all these formulas. So we have only one formula as of now. These formulas we have already studied in last year, that's in your strength of materials. So tau is equals to mu into du by dy. Tau is called as shear stress. The unit of shear stress is Newton per meter square, also called as Pascal. Next, mu is called as dynamic viscosity or simply viscosity. This is the SI unit of mu. du is called as velocity, the SI unit of velocity is meter per second, dy is thickness, the SI unit of thickness is meters, du by dy is called as velocity gradient, the SI unit of velocity gradient is per second. Sometimes kinematic viscosity will be given in the question. So kinematic viscosity nu is the ratio of mu by rho, okay, and sometimes he will also ask you to find out the value of power. Power is given by 2 pi nt by 60. So this T you will get from, again you will get this T with the help of this tau only, because tau is equals to force by area. So once we get tau, we can find out the value of force. This force we can substitute in the formula of torque T, and this torque T can be substituted in the formula of power in order to find out this. Okay, so we will be solving some more problems based on Newton's law of viscosity, and I will also be solving previous problems so that you will have more confidence, which will help you solve problems in the final exam. Okay, so the next question, I'll take up the next question from Newton's law of viscosity. Next problem. Yes. Okay, I'll read out the question. The dynamic viscosity of an oil used for lubrication between a shaft and sleeve is 6 poise. Okay, so the value of viscosity is given in the question. Viscosity is given as 6 poise. I told you in the last class, 1 poise is equals to 1 by 10 Pascal second. So Pascal second is the SI unit of mu, not poise. So in place of poise, I have to write down 1 by 10 Pascal second. Okay, so this is the SI unit of mu. So what is the value of mu now? 0.6 Pascal second. So Pascal can also be written as Newton per meter square into second. Okay, so this is the SI unit of mu, not poise. So whenever poise is given, just divide it by 10. That will be converted in terms of SI unit, that is Newton per meter square into second. And number of times it will be given in terms of poise only. Next, the shaft diameter is of 0.4 meters. So diameter of shaft has been given in the question. Diameter of shaft D is equals to 0.4 meters and rotates at 190 RPM. So what is RPM means? Speed. So speed of this shaft is given as 190 RPM. So speed we will denote it by capital N. So 190 RPM, that is rotations per minute. Next, calculate the power lost in the bearing for a sleeve length of 90 mm. So length of this shaft is given as 90 mm. So this is length. Next, the thickness of oil film is 1.5 mm. So thickness of oil film, thickness will be denoted by dy. So thickness is given as 1.5 millimeters mm. First we have to see whether all the given units are in the SI form or not. Meter is SI form, okay, rotations per minute. Millimeter is not our SI form, so we have to convert this in terms of meters. So I know that milli means 10 power minus 3. So in place of milli, I will write down 90 into 10 power minus 3 meter, millimeter. So milli means 10 power minus 3. So in place of milli, I have written 10 power minus 3 meter. So this is coming out to be 0.9 meters. Okay. Next, sorry, 0.09 meters. Next, the value of dy is also given in terms of millimeters. So 1.5 into milli means 10 power minus 3. So in place of milli, I am writing 10 power minus 3 meters. So I will read out the question once again. The dynamic viscosity of an oil used for lubrication between a shaft and sleeve is 6 poise. So you have a shaft, there is a shaft So this shaft has a diameter of 0.4 meters and this shaft is running at a speed of 190 rpm. So this is rotating at 190 rpm. Okay, it is rotating at 190 rpm and it is supported by a sleeve. Sleeve is always a supporting member like a bearing. So you have a sleeve which is supporting this shaft while rotating. The shaft is rotating and the sleeve is providing support to this shaft. So this sleeve, there is a sleeve. So we will assume this to be sleeve which is providing support to this shaft. And in order to, why we are using oil in between these, that is to avoid, so there is oil in between this, between shaft and sleeve, it is filled with oil. Why we are filling it with oil? Because we have to reduce friction. So lubricants are used in order to reduce friction. So when this shaft is rotating at 190 rpm and it is being provided with a support by sleeve, so this space between shaft and sleeve is filled with oil in order to reduce the friction. So this viscosity of this oil has been given in the question, that is 6 poise. So after converting it into SI units, that is 0.6 Newton per meter square into second. Okay. So next the diameter of shaft is given, speed of shaft is given, length of this sleeve is given. Okay, this length, the entire length is given, that is given as 90 mm, that is 19 to 10 power minus 3 meter. Thickness of oil film is given. How much thickness is being provided? Okay, that is given in the question, that is 1.5 mm. So 1.5 mm is the thickness of the oil film that is given in between shaft and sleeve. So you have to find out the power lost. Okay, you have to find out the power lost. So what is the formula of power lost? We know that the formula of power lost is 2 pi nt by 60. Okay. What are the terms which are given in the question? 2 into, we know the value of pi, n is given in the question, we have to find out torque. Now what is torque? Torque is force into radius. Okay, I can find out the radius because diameter has been given in the question. Diameter is given as 0.4 meter. So radius is half of the diameter. So force into, I can write down radius as diameter by 2 because radius is half of the diameter. I have to find out the value of force in order to find out torque. Now, in order to find out force, I will use my Newton's law of viscosity. So, what is Newton's law of viscosity? Tau is equals to mu into du by dy. Okay. So, tau is given in the question? No. But what is tau? Force by area. So in place of tau, I am writing force by area. Mu is given in the question, 0.6 into du value is given in the question. So du is given as, what is the value of du given? Okay, du has not been given in the question, but we can find out the value of du by using the formula pi into d into n by 60. Velocity is pi d n by 60. So pi into d, diameter is given 0.4 meters into speed of the shaft is given as 190 rpm by 60. So you can find out this value in the calculator. Pi into d value is 0.4 into n is 190 by 60. Okay, so du value you are getting as 3.97 meter per second. So velocity formula is pi d n by 60. Okay, we have already learned this in the last year also. So du value I got as 3.97. So whenever speed is given, you can find out velocity. There is this famous relation, velocity is equals to pi dn by 60. Like if you have a tire which is having a radius of 1 meter, or let's say diameter 1 meter, and if it is rotating at let's say 100 rpm, you can find out with what speed my vehicle is moving. So my vehicle will move, the diameter is given as 1 meter, pi dn by 60. So with the help of this formula, you can find out with what speed your vehicle is moving, the diameter of tire and the rotations the tire is taking in 1 minute. So that velocity formula is pi dn by 60. So this is also rotating, my shaft is rotating, it is rotating at 190 rpm. The diameter of shaft is 0.4 meters, so you can find out the velocity pi dn by 60. So 3.97, I got it as 3.97 meters per second. dy is given in the question as 1.5 into 10 power minus 3 into 10 power minus 3. So area, whenever diameter is given, I can find out area. So area is pi by 4 d square. So if I substitute here, force by pi by 4 d square, what is diameter given as 0.4 meters. So force by area is pi by 4 d square is equals to 0.6 into 3.97 divided by 1.5 into 10 power minus 3. So from this you can find out the value of force. So force, this will multiplied here because it's in the denominator. So pi by 4 into 0.4 square into 0.6 into 3.97 divided by 1.5 into 10 power minus 3. So you will get the value of force. You can find out this value in the calculator, and you will get the value of force as 180.05 newtons. So once you get the value of force, you can find out torque. Torque T. See, don't get confused between T and tau. So I have written tau here. Okay. So this is a little bit wavy. The upper head of this is a bit wavy. So torque is a T, capital T is torque here. Okay. So torque formula is force into radius or force into diameter by 2. So force I got as 180.05 and radius is half of the diameter, so diameter by 2. So 180.05 into diameter value is given in the question 0.4. So 0.4 by 2. So you will get the value of torque, and it's coming out to be 36.01. 36.01 Newton meter is the unit of torque. So once you find out the value of torque, you can substitute torque in power. Power is equals to 2 pi nt by 60. So 2 into pi into the value of n is given in the question 190 into n is given in the question. Okay. Next torque we got T 36.01 by 60. You can find out this value in the calculator, and that's coming out to be 716.48 watts. Okay. So that's how the problems are asked in the previous exams also. We will be solving those problems as well. I will take up few examples, few problems which has been asked in the previous exams. So I will solve some questions from the previous exams. Okay, you can download this app, OU Papers. So in 2016, Okay, the latest paper which is available here I have is 2016. So I can see part B, 11th question, 2016 I have here. If you find any latest papers, you can send it to me on WhatsApp. So 11th question, B bit, there is a problem on Newton's law of viscosity which has been asked for 5 marks. A cylinder of 100 mm diameter of cylinder has been given as 100 millimeters. So I know that milli means 10 power minus 3. So 100 into 10 power minus 3 meters. So that is 0.1 meter. So whenever diameter is given, you can find out radius. Radius is half of diameter. So 0.1 by 2. How much will be? How much this will be? 0.05 meters will be the radius. Okay. So diameter is given as this value. I have converted that into millimeters into meters. So I got this value. I got the value of radius. Okay. Next, and 300 mm length. Okay, length has been given as 300 millimeters. I know that milli means 10 power minus 3. So 300 into 10 power minus 3 meters. So that is 0.3 meters. Okay, next I'll read out the question further. Rotates about a vertical axis inside a fixed cylinder of 105 mm diameter and 300 mm length. Okay, so the diameter, it's rotating, this cylinder is rotating inside another cylinder which is having a diameter of 105 mm. See, this is an interesting question. There are two cylinders. One of the cylinders is rotating inside another cylinder. Like we can take one example of this cap. Let's say this pen is rotating inside this cap. So this cap is a hollow cylinder and this is a solid cylinder. So I have two cylinders here. So I will take the diameter of first cylinder because this dimension is lesser than this dimension. That's why I am able to get this cylinder inside this cylinder. So I will take the first cylinder as small d because this diameter will be the smaller diameter and this radius will be the smaller radius. Okay, and this cylinder is rotating inside another cylinder. So let's say we have one cylinder, hollow cylinder. Okay, inside this hollow cylinder you have one more cylinder which is rotating inside it. Okay, so this cylinder is rotating inside this cylinder, the red cylinder, as per the question. So the diameter of inside cylinder is 100 mm. So diameter of this inside cylinder is 100 mm. And the diameter of the outside cylinder, the external cylinder, is 105 mm. Okay. And lengths are, okay, the length of both the cylinders are 300 mm. So this is 300 mm is the length. So length is 300 mm, that is 0.3 meters. Okay, in terms of meters. Next, if the space between the cylinder is filled with oil, with liquid of dynamic viscosity. So dynamic viscosity of that oil is given as 0.125 Newton by meter square into second. Okay, so this space, so this cylinder is rotating inside this outside cylinder and this space around 360 degrees, it is filled with this oil which has a dynamic viscosity, which has a stickiness of 0.125 Newton per meter square into second. Okay, so this is oil, completely this is oil. Okay, so next, what is the thickness of this oil? You can find out the thickness of that oil. Determine the speed of rotation. Okay, you have to calculate the speed. You have to calculate the speed of rotation of the cylinder, which will be obtained if the external torque is 1 Newton meter. Torque has been given in the question as 1 Newton meter. Okay, so first, with the help of torque, what is the formula of torque? Force force into radius is equals to 1. The formula of torque is force into radius. So in place of torque I have written force into radius is equals to 1. Okay. So now what is shear stress tau? Shear stress tau is force by area. So can I write force as shear stress into area? Okay. So in place of force I can write down shear stress into area into radius is equals to 1. So I have the formula of tau from Newton's law of viscosity. So tau is equals to mu into du by dy, that is Newton's law of viscosity. So in place of tau I am writing mu into du by dy into area into radius is equals to 1. Okay. So mu into, in place of tau I have written mu into du by dy into area. So in place of tau, mu into du by dy, area as it is, radius as it is. Okay. So mu value has been given in the question. So the value of mu is 0.125 into, what is du? Velocity formula. Velocity formula is pi dn by 60. So in the denominator I have dy here, so into dy into area. So whenever diameter is given, you can find out the value of area. So diameter is 0.1 meter. So pi by 4 into 0.1 square, and what is radius? 0.05 is equals to 1. Now what is this dy here? Okay, so in the next step 0.125 into pi into, okay, what is diameter? Okay, diameter is 0.1 into speed I have to find, divided by 60 into the value of dy. Dy is the thickness of this oil film. So what will be this value? This total value is 105. 105 minus 100. So I will get these two values. If I do 105 minus 100, so what's remaining? 5. So this 5 will be divided here, 2.5, and this will be 2.5 mm. So the thickness of oil film dy is 2.5 mm. So 2.5 into 10 power minus 3 meters. So I got the value of dy. In place of dy I can write down 2.5 into 10 power minus 3 into pi by 4 into 0.1 square into 0.05 is equals to 1. How many unknowns do I have? I have only n, which I can find out by taking that n, separating that n from all these values. So what will be n now? 1. Just cross multiply this, it goes to the numerator. So 1 into 60 into 2.5 into 10 power minus 3 divided by 0.125 into pi into 0.1 into pi by 4 into 0.1 square into 0.05. So you will get the value of n. If you substitute all this in the calculator, that will be in terms of RPM. So this question has been asked in 2016 for 5 marks. Okay, I will re-explain this solution once again. So there are two cylinders. One is inner cylinder and another is outer cylinder. The diameter of outer cylinder is 105 mm and the diameter of inner cylinder is 100 mm. So this inner cylinder is rotating at a speed of how much? You have to find out. The length of both the cylinders is given as 300 mm. So I have converted this into meters. And the space between these two cylinders is filled with oil, which has a viscosity of 0.125 Newton per meter square into second. Okay. So the torque is given in the question. With the help of torque, you have to find out what is the value of speed n. So see how I am finding out this value. I know the torque is force into radius. So force into radius is equals to 1, which is given in the question. So force can be written as shear stress into area. Stress into area is force. So shear stress into area into radius is equals to 1. Tau value as per Newton's law of viscosity is mu into du by dy into area as it is into radius is equals to 1. So mu value has been given in the question. I have substituted that value. Du is pi d n by 60, dy as it is, into area is pi by 4 d square. Area of cylinder cross section area is pi by 4 d square into radius is 0.05 is equals to 1. Okay. Now this dy value I got it from this, that is the thickness. What is the gap of this? That is 105 minus 100. So 5 is remaining. So this 5 will be divided here and here. So this will be 2.5 and this will be 2.5. So dy value, that is the thickness, I got as 2.5 millimeters. So 2.5 into 10 power minus 3 meters. So in place of dy I have substituted 2.5 into 10 power minus 3. And from this there is only one unknown n, so I have separated that n and I got this value after substituting in the calculator. Okay, that's it. So I will take one more problem. Okay, I will take one more problem in the next video. Okay, that's it for this session. Thank you.